Hello and welcome to this PV Tech TechTalk product series webinar co-hosted with JinkoSolar. The title of today's webinar is Assessing the Benefits of TOPCon PV Modules for Utility Scale Solar LCOE. My name is Liam Stoker and I'll be your moderator for today's webinar. And joining me today are Roberto Magione, Head of Technical Service and Product Management at JinkoSolar Europe, and Xiaowei Wei, Operation Director for Balancer System and Energy Storage Systems at TÜV NORD. Before we start, some housekeeping. Today's webinar will last approximately 1 hour. Shortly, Roberto will open proceedings by explaining Jinko's adoption of and shift to TOPCon PV modules, followed by Xiaowei, who will detail TÜV NORD's recent assessment of how such products can benefit the LCOE of solar PV projects. Following those discussions, we'll host an audience Q&A, so if you do have any questions, please use the dialog box on your screen. We'll work our way through as many questions today as possible. If we're unable to get round to your question, please provide your email address and we'll liaise with you directly. The slides and a recording of today's webinar will also be available shortly after the presentation. But without any further ado, we'll hand over to Roberto to begin today's webinar.
Thank you very much. It's a pleasure for me to be here. Welcome everyone. Today is my big pleasure to introduce you the TOPCon technology. We will go through why TOPCon, what is exactly the new technology of our cells, and we will speak about these trends and why it is going to be a game changer in the future of this PV technology. Well, let's get it started. First of all, why? What there is behind this change? Well, essentially, the efficiency limit of P technology is the core point on why we are moving on. If we analyze the cell efficiency record that we have reached in the years, we can check the black line, the black curve, and we realize that it's becoming flat. It's becoming flat because we are almost have received the limit in technology. And this is a huge limitation for the future in terms of PV solar module technology. We have analyzed the different cells technology right now available in the market, IBC, heterojunction technology, TOPCon, and we have checked the TOPCon efficiency, which is now on mass production that we can receive. It's 24.5%. And by analyzing also the efficiency limit, which is 28.7%, we have based our strategy for the coming years. So we set the top of 29%, and we decided that in the 5-6 years to come, we will strongly deliver and develop TOPCon technology. Well, in terms of, let me say, market technology of N-type, we have started delivering the first generation in the last 2 years of PERC technology, and then we had definitely decide and check what is the technology to go for mass production, because initially we delivered only this technology for residential market like a niche technology, but we wanted to go for mass production. We wanted to be aggressive also in the utility market, not only in the residential. So we have compared the two technologies, the two main technologies, which are TOPCon and heterojunction. And here we can see a clear differentiation of the structure of the cell between PERC, TOPCon, and heterojunction. By comparing the two technologies, we realize that the cost to process, to realize, to combine the layers of the heterojunctions is definitely higher. Plus, it is going to use also amorphous silicon field. Then we decided to apply TOPCon. So the main reason is that we can easily switch our P-line cells to TOPCon cells facilities, plus is less expensive, generally speaking, and we can reach the same top technology level of the technologies. Thus, we realized TOPCon. We called internally, our internal technology is HOT2, because we use a tunneling layer technology, which is the key layer of these sub structures. And let's analyze better this technology. So the tunneling layer is the key because it is going through heat passivation to reduce the resistance loss and increase the carrier recombination. So definitely this particular tunneling layer is going to increase the carrier recombination. This is key because we reduce any specific losses when we are speaking about p-n junction, when we are speaking about holes and electrons combinations. And applying this technology to the cells and then making models, we realize that from the cost, from the mass production, we can definitely beat P-type on the market, and we can exchange, we can switch completely the technology. And we realized a new family called Tiger Neo, which is basically 5 types of modules that can be applied in utility scenarios, commercial scenarios, and obviously also residential scenarios. Let's check the family in details. So we have the Tiger Neo 78 cells configurations with a maximum of 615, 610 watt peak. We can offer this technology, obviously addressing the utility market in monofacial and bifacial dual glass option. We have also the medium Tiger Neo 72 with a maximum power of 575, 570. We have also the mono bifacial configuration dual glass for this specific model. Plus, we have the Tiger Neo 60 and 54 addressing more residential and commercial markets. Both they have only monofacial, and the Tiger 54 can also be equipped by whole black configuration, so all frame and the back sheet completely black for cosmetic aspects. It's a premium product which will come with 25 years product warranty and 30 linear power warranty. Let's speak about advantages of this technology. Well, what are the benefits of this huge change that Jinko is proponing to the market? Well, first of all, less degradation. First of all, the 30 years power warranty. Why? Well, in short, with N-type, we can almost eliminate LID effect, which means that the very first year, the degradation compared to P-type will be the half, so only 1%. And also the linear degradation will be limited to minus 0.4% per year. So this is a, let me say, a very impressive improvement, because in the 30 here, the blue part, you can translate it in energy gain, which is going to strongly increase the energy yield on the field, just having less degradation, of course. Also, temperature coefficient. This is a very important topic, specific on the areas where the environmental conditions are quite aggressive in terms of temperature. Well, here in this graph, we see the cell temperature and the power in correlation. And we can analyze on how the cell temperature is growing and how the temperature coefficient is effective, which means that from P-type, we had in the past minus 0.35%. With N-type, we improved to minus 0.30%, which means that at every conditions, the response on the temperature will be better on N-type. And the higher the temperature, the better the response will be of N-type, up to 3% when we reach 85 degrees at the cell temperature level, of course. Another key point of this technology is that will come naturally with a higher bifacial factor. So from P-type, we can increase 70% to 80%. So this is a strong benefit when it comes to designing and when it comes to applying bifacial technology, because with this significant power gain, we will also have energy gain, which can be calculated between 2 and 3% compared to P-type. So we can go up 85%. So the medium, the average that we will guarantee will be 80% as a standard. Not to mention, obviously, reliability, which is a very key point for investors and for us as well to deliver. We have tested the N-type technology with all the IEC tests. And for every test, starting from thermal cycle, finishing with PID, we can see that we reached a better value compared to P-type. So this is a clear indicator that the N-type can deliver excellent performance, better than P-type. Obviously, under the red line is 5%, which is the limit set by the standards. But you see the blue graph, it's always performing better than the gray graph, which means it's definitely a more reliable technology. It's not only about reliability, but it's also about performances. And coming back to performances, we can see that N-type technology has a higher internal resistance, which is going to increase naturally better the low light response. What does it mean? It means that this kind of technology will start providing energy before early in the morning and will finish produce later in the evening. Definitely is going to increase the energy output of your PV plant. Here we see a difference between P-type and N-type and how the gap is increasing when we go to low light part. So 400 watt per meter square, 200 watt per meter square, N-type is performing constantly better. In terms of technology that we also apply to N-type, we have studied a circular ribbon, particular circular ribbon to apply on top in order to increase the internal reflection. After analyzing the triangular ribbon and the circular ribbon, we checked and we saw the results that it's definitely better in terms of energy production. And not only we are applying the particular shape, but we are also improving our technology, and we will apply the called slim multibusbar technology, which will improve the response and we will increase the energy output. Not to mention that this kind of technology will also increase the solidity of the cells by decreasing the cracks, by decreasing the possible cracks. So the cell will be more solid, more robust. And so the actual technology from Jinko is called multibusbars. And for 182 cell sites, we have 13 multibusbars. And we will move to 16 multibusbars. We apply a ultra fine soldering wire, and this will help us to also reduce the internal losses in the cells. So let's us now make a summary. Let's try to gather all the benefits, because the final important key point to better understand this technology is the improved energy generation. So if we, let me say, collect the optimized temperature coefficient, the higher bifacial gain, the lower LID, the better response on the low light performances, then we can reach an average of 3% energy more compared to P-type. This is a huge step towards energy yield, towards more in performances. And we have analyzed, we have made several tests that are also more ongoing, more than 1 year calculations, and we have checked the difference between a bifacial P-type and bifacial N-type and the power generation. difference reaches up 3%. So can reach also 4%, 2%. Of course, it's case by case, but definitely N-type is performing much better than P-type. Here in this case, we can see, depending on the radiance and the power gain, also we have the timeline, how always the red line is performing higher power than the blue line, which is P-type. And if we now switch and we use, let me say, our values in terms of energy, in terms of power, in terms of output, we can also compare the LCOE for utility scale plants. Here we have a just small comparison between Jinko N-type and 210 P-type from a competitor, and we see how the energy more produced from N-type is going to make a huge difference in your numbers, specifically on IRR, which is going to increase by 5%. LCOE is going to be reduced by 6%. Even the BOS, the cost of BOS, is going to be reduced more than 1%. So the power gain, which is calculated in this specific simulation, is going to definitely make the difference in your business plan. This was a case of 200 megawatt peak in Mongolia with a fixed installation system, but we can also check how the difference is impressive in trackers. So we have made other two simulations, one in Saudi Arabia, the other one in Spain, with trackers. And taking N-type as a benchmark, we see how the different technologies of competitors are always going to increase the BOS and the LCOE. And for making this calculation, we have checked any particular data of the business plans, the AC cable installation, the tracker installations, any kind of cost has been calculated, because it's very important to check how this technology is going to completely change the DC structure, improve the energy yield, and increase exactly the IRR of your investment. When it comes to LCOE, of course, we have also to check system design and compatibility. So our N-type family technology is 100% compatible with all the string inverters in the market and central inverters. Right now, the market is 50-50, which means 50% of the PV plant in Europe are designed with string inverters, the other 50% with central inverters. With both kind of technology, Jinko Power is delivering 100% compatibility. This is a very important point for designers. 100% compatibility also with fixed multi-system and trackers. We are using the same frame technology we are using for P-type, so we also will deliver the same mechanical values, 5,400 Pascal in front and 2,400 Pascal for the rear side pressure. And we are all, obviously, according to our manual, we are also compatible to Next Tracker, Artec, Soltec, all the main trackers producers. Let's check what are the Jinko plans on this technology. Well, I have to say that we have huge plans, because Tiger Neo will reach by the end of this year 42 gigawatt capacity, which is quite impressive. Which, if we consider that by the end of the year, Jinko will have 60 gigawatt capacity of total production, and 42 will be on N-type. This is a clear indicator on how Jinko wants to drive the market towards N-type, because we consider the natural coming technology after PERC, there will be N-type TOPCon, and this is what we strongly apply in our strategic product facilities. We have started the mass production in February, so we just started, and we have already 2 factories running at 16 gigawatt capacity. By the end of the year, it will be 42. So what's what's the takeaway? Takeaway is that N-type is coming. It's coming strongly, and in our opinion, will completely take the scenario step by step in the coming years, and will replace P-type technology simply because it's a superior technology for many aspects that we just checked, and it's delivering a higher power density. It's moving the technology in a superior step, which is going to be applied, in our opinion, into the main countries in Europe. And that's it. Thank you. I'm open for any doubt or any question that you would like to have. Yeah, I leave the speak to Liam now.
Great. Well, thank you very much, Roberto. I'll hand over directly to Shawi to continue the presentations today.
Thank you very much, Liam, and thanks very much to Roberto about detailed technical aspects on the product. So my name is Shawi Wei from TÜV NORD, and today I will share more information on the system end. The topic of my presentation is the analysis of influences on LCOE by PV modules with different technologies. So a little bit background information about TÜV NORD. So we are a third-party technical service provider who focus on safety, security, and success through knowledge. We had about 55 gigawatt worldwide PV system performance evaluation and over 3,000 certificates issued for the PV modules and its component. So let's talk about the background of today's PV industry. And we can see that from all kinds of mainstream market analysis agencies, even with different numbers and this hard situation caused by the COVID, we can see there are still a huge increment on the installation of the PV modules. So what has been very much important in the blooming of the PV system is the LCOE evaluation, which is the levelized cost of energy. So here we see a formula regarding how to calculate LCOE. So basically, it's the life cycle cost that the overall cost during the system operation in the overall lifetime, to be divided by the lifetime energy production, that is the energy yield during system operation time in the lifetime. So in the formula, we can see there are some similar parameters that for each projects, they are generally very close to each other, while there are some variables that may have impact or big impact on the final calculation of the LCOE. So the green marked ones are the variables, which is total investment capital and the operation and maintenance fee over the lifetime, the tax you will pay over the lifetime, the land fee that you will pay over the lifetime, and the overall generated energy. So why we talk about LCOE? It is because that LCOE is indicated to be dropping down since this year, and of course in the before, and to keep the LCOE in a trend of decreasing is helping the PV industry to develop with bigger opportunities in the market compared to other renewable energy forms. So LCOE is quite important, and and we shall keep it as low as possible. But it's also a comprehensive thing that the LCOE is not only impacted by one factor. And now in the market, we see a lot of emerging technologies for PV. So currently the mainstream is the PERC. And now we see different roadmaps to TOPCon PV module, TOPCon cells with the N-type cell. And also another option is to go for the HJT. But we can see the TOPCon module, TOPCon cell is now going to be the more mainstream, because it is compatible with current production line of PERC, and a lot of cell manufacturers already are transforming the production line from PERC to the TOPCon. And based on the evaluation from TrendForce, that the N-type cell production will have a huge blooming starting from this year, 2022, and keep climbing up to a very high portion in the overall in the market of the PV modules. So then we make two PV systems, one in Spain, Lorca, and the other is in the Gonghe city in China, to compare the LCOE of different PV module technologies under the same DC capacity and the same location, and see which has a better performance of the LCOE. So the one in the Spain has a more moderate weather condition, while the one in the Gonghe city in China is much cooler, but it also is simulates some areas of the Europe. So let's now look into detail of the LCOE evaluation for the Spain project. So here we have two cases installed, or we say simulated, in the system in Lorca, Spain. And it is listed here and have several highlighted parameters in green, we can see on the screen, which is the, we say, the advantage of the Jinko's PV module using the TOPCon technology. The temperature coefficient of power output is better. The module efficiency is higher. The bifaciality coefficient is also higher. It's 80% compared to the regular 70% of the PERC module. And the degradation of the TOPCon PV module, starting from first year and starting from the second year to the end of the lifetime, are also much less than the one using the PERC technology. So we simulate the power generation, overall power generated by the system using PV-Syst, and then we count into 30 years of guaranteed lifetime of the module, and then we got the overall energy yield between the two projects using two different PV modules. So due to the higher module efficiency, higher bifaciality coefficient, a better temperature coefficient, and also the low power degradation every year, we can see that the one using the Jinko's TOPCon PV module has 2.7% higher overall energy yield in the 30 years during its lifetime. And then we can look into the CAPEX of the Lorca project. We assume the 4 factors like PV module and inverter, the design and development, and some other costs that is irrelevant with the module type are similar or same. And there are some major cost differences on the tracker, electrical system, installation cost, and land lease cost. The total project investment of the two different designs, we can see the Jinko ones has lower CAPEX. And looking into the detail, we see that because the power for each tracker is higher, then we got 5.52% better performance of the Jinko's module compared to the other one. And due to the other one is using 210 millimeter PV module, it has a higher current, so we have to use the DC cable with larger diameter. Therefore, the electrical system costs are also higher, and the module which is larger are also difficult to be installed, and with the same ground coverage, because the PV module efficiency are different, and higher efficiency will also means to have less land, and the land lease cost will also be different. So these are the four main factors we see during the simulation when we calculate the CAPEX. And finally, we use the LCOE formula we just mentioned to calculate the overall LCOE result of the two different projects. And we see that the Jinko's module with TOPCon technology has 4.33% less than the other one using the PERC technology. So next, we can look into the LCOE evaluation for the Chinese project. It's similar. We have three different installations or three different designs. One using the Jinko's PV module with TOPCon technology, the other two using the PERC technology. They are with the same advances we just talked about. The same method we use by PV system to calculate the initial energy yield and then the overall energy yield over the 30 years. And we got a very similar result to the Spain project, that the Jinko's module has around 3% more energy yield than the other two projects. And for the same reason, we see the CAPEX, the total project investment of using Jinko PV module is less than the other two. For the same similar result, we can see the power, higher power per track, different usage of the DC cable, and the different size of the module, and the different ground coverage rate. Jinko's PV module has better performance than the other two. And by final calculation of the LCOE, we can see that Jinko's module has over 3.5% better LCOE than the other twos. So for the conclusion, we can see that when the unified DC site capacity, land availability, system design principles, and module prices are determined, we can see the N-type products by Jinko have great advantage in terms of the cost per kilowatt hour and profitable investment in the large-scale ground power station projects in Spain and China. So the main advantages are 3 points. First one is the high efficiency modules, which can greatly reduce the initial investment cost of the project, such as the modules, the BOS equipment procurement cost, EPC construction cost, etc. Secondly, it can reduce the land area required by the plant, and therefore it will reduce the annual land lease cost. And thirdly, Jinko's N-type module has lower power degradation and higher bifaciality coefficient, which also helps with to reduce the LCOE. So thank you all for today. This is my presentation, and any questions are also welcome. Thanks.
Excellent. So, like I said, I think we were just after a bit more detail around the real core LCOE benefits of N-type modules.
Yeah, sure. I mean, just to be more specific, well, we know the formula of LCOE, and we basically understand that the major contributor here is the energy factor, which is going to change dramatically your business plan, because, I mean, definitely the energy more is going to have an impact on the, not really on the BOS cost, rather on the profit, rather on the energy that you can gain by using this technology. So in short, we have calculated, we have now tested this technology since 2 years. We have tested in our internal field facilities since almost 1 year. And we have reached an average of 1.5% energy more when it comes to monofacial comparison and 3% energy more when it comes to bifacial comparison. And this energy more, of course, should be calculated depending on the PPA conditions on the country, on, so you have to apply your LCOE calculations. I suggest to take our LCOE calculation as a strong reference point, of course, but of course, yeah, you have to apply it in your country and your specific business plan. And yeah, definitely, it's all about not only more efficiency and more power density, but specifically it's more energy that you can produce at the same conditions, comparing N-type with P-type. That's the point.
Excellent. And I'm just pouring over some of our questions today from the audience. I know a lot of the presentation was around utility scale solar and the N-type application there. I know in your presentation, Roberto, you stressed the availability of a 60 or 54 cell format for residential and or CNI. Could you perhaps give a bit more kind of thought around the application for N-type modules in those kind of applications, because there hasn't perhaps been a bit too much focus on their application there?
Yeah, no, sure. Well, yes, we did. Well, indeed, we have to say that N-type technology, we started with the first generation PERC technology since 2 years ago, mainly addressing the residential. Right now, with the new family, which is Tiger Neo, with new dimensions and new cell size, which is 182, we are actually addressing all the sectors. So we have utilities, we have commercial, industrial, and we have residential. Specifically for residential, to be honest, we have designed the Tiger Neo 54, which is around, just to give you an indication, 1.7 per 1.1 meters. And this is perfect to handle. It's been tested by the installers, and we have an excellent feedback. And we can deliver it either standard configuration or all black. And not to mention that all black will be a premium product, because we will deliver it with 25 years product warranty, which is on top of the category, and 30 years linear power warranty. So definitely we have specifically designed a product for residential market by using TOPCon technology.
Excellent. Kind of just trying to pick up a few of the questions at once. There was some discussion around the capacities that JinkoSolar are expecting to have going into the rest of this year. I know there's, I think it was 60 gigawatts of modules in total, with 42 gigawatts of which is kind of intended to be N-type, which would suggest there's quite a lot of that N-type shift might be happening a lot quicker than many people expected. How quickly do you foresee this going on kind of beyond 2022, for example?
Yeah, sure. Let me explain our strategy, which is quite surprising. But so for this year, we plan to have in-house 50 gigawatt wafer capacity, 45 cells capacity, and 60 gigawatt module capacity. So initially, by the end of last year, we planned to gradually launch N-type technology and have planned for 2022 around 10 gigawatt capacity. But after receiving an excellent feedback from customers and by analyzing the demand, we think that this switch will be happening faster than we think, and that's why we completely changed our strategy, and we decided to immediately go for N-type. And instead of be ready to have 10 gigawatt this year, our plan is to have around 40 gigawatt, which is going to be a huge percentage of our capacity. So we see the TOPCon technology, the HOT Jinko technology, too, coming has a strong game changer. It is the natural switch from P-type to a N-type. I explained in my presentation that unfortunately with P-type we cannot anymore, how to say, improve the efficiency. So that's why we switched to TOPCon. And I don't see. I saw a question regarding the price dropping down of P-type. I don't see this happening. I maybe see the N-type going to match step by step the P-type level, but not the P-type going down right now. That's my view.
Excellent. And could you perhaps go into a bit more detail around the main difference in characteristics between N-type and P-type? It's something that quite a few of our attendees today were after a bit more clarity on, obviously, in the kind of backdrop against the benefits of one over the other.
In terms of benefits, I've described, during the presentation, the main one, which are the temperature, the lower temperature coefficient. We are almost going to eliminate LID, which is a huge step. The small part of LID which will remain is just due to the impurities that we will have. And this is something that physically it's almost impossible to eliminate. But just to give a reference, we have analyzed, and the level of LID that you can set in your PV system is going to be around 0.2, 0.3. And not to mention that we have already the PAM files third-party certified, so we can provide already the PAM files, and they are already certified by a third laboratory, and you can already start designing and check the difference with P-type. Of course, it's only a simulation, but it's going to support a lot the designers and the investors right now.
Excellent. And obviously, the benefits that we've seen highlighted in the presentations today, and some of your speeches already, Roberto, in the kind of temperature coefficient, low light environment, bifacial. Does that make the kind of N-type modules more beneficial, or even kind of those benefits become even more apparent in particular markets or geographical locations?
Well, yeah, of course, depending on where you are, this kind of benefits are going to have an impact in your performances. Specifically, if we speak about Central America, Middle East, where the hot temperature, aggressive environments are a key factor for the designers to check properly the performances of the PV plants. Definitely, we have seen how the lower temperature coefficients are going to play a key role here by having a better response compared to P-type. And not to mention that this is about very hot conditions. But if we go in the northern part of Europe, if we go in different areas where we can take advantage of another benefit, which is the low light performances, which are better with N-type, naturally better. So the point is, according to our calculations, according to our tests, we have seen that in every conditions, N-type is performing better. There is no discussion on this. It really depends location by location, of course, to check and to properly make a simulation and understand the different benefits.
Okay, fantastic. Just pouring over some more questions from the audience. If you do have questions, once again, do feel free to send them across, even if we don't get around to answering them today. We will endeavour to answer them privately as well. Just picking up another question here, Roberto. We've kind of looked at the fact that there's specifically for the utility scale segment, there's a 72 cell and a 78 cell format. Could you perhaps go into a bit more detail around why with the kind of reflective benefits of those two particular formats over each other, and how they might apply to different environments or projects?
Yeah, sure. So I would like to reply to two questions. One, I see that someone asked if when we expect the first deliveries in Europe. So we started officially producing on February. So we expect the first deliveries to come in April, May. Okay. So Yeah, and regarding the two specific products, the 72 and the 78, they will come monofacial and with bifacial block glass options. So usually, you know, both products are going to, we think are going to satisfy the majority of the demand of utilities, because the 72 is much more flexible because it's a bit shorter. So even where we have a strong wind or strong mechanical values requirements on site, we suggest the 72. When it comes to normal areas, you can also go for 78, which is 20-25 centimeter longer, which is making definitely the structural calculation a bit more critical. But if your environment allows you to use such a product, why not? So it really depends again on the location. It really depends on your design, if it is trackers, if it is fixed installations. So that's why we would like to give the both options to our customers. So depending on the design, on the target of the customer, we can suggest one or the other product.
And then I guess further, sorry, just to, I know there are some people still having some audio difficulties. If you do refresh your page, it will completely solve that. So if you are still having that, the simple task is to just refresh. I guess, Roberto, another question here from the audience. It was mentioned that the power warranty for the N-Type, the Tiger Neo would be 30 years. Is there any recommendation around the financial modeling inputs for a project with a planned lifetime of 40 years or beyond that in terms of degradation, failure rate, that kind of thing?
Yeah. Well, the degradation will follow the same model. So the market standard now sets 30 years for N-Type, but for specific project we can discuss till 40 years. So it's something that we can discuss. But in any case, the normal degradation will follow the standard formula of minus 0.4%. I see that Xiaowei has joined the club. Hello.
Hello, guys. Sorry for the network problem. Hello.
Excellent. Well, thank you very much for returning, Xiaowei. We have a few questions here for you, actually. If I could just bring them back up. So there was some kind of questions. The format of the projects that we used in the study. Some projects were in 1P format, others were in 2P. Could you perhaps give your kind of insight into the differences between the two projects that we used in the simulation?
It's just two different designs of the power plant. It's not just we compare with the same design, using the same trackers in the same place, same project. It's not like we use 1P and 2P for one same project. It's just two different. And of course, we can use 1P in Spain and 2P in China. That's all okay, but we set the baseline same with one same project location, so it's not a problem. If you would like to, we do more calculation using different installation method or different module types, different kind of module technologies. We can also do it later and share the data afterward.
Excellent. Another question for you, Xiaowei, again, that was based on the study. I'm not sure if this was revealed on the page or not, but really, when it came to kind of the P-type products that we used, whether the wafers gallium or boron doped, could you reveal that at all?
Sorry, can you repeat? I don't get it.
The wafers that we used in the P-type, the comparative project, that we used in the study. Do you know if they were gallium or boron doped? There was just a really specific question that was asked.
You need the module types for the different project, right?
Yes.
So one is using the 182 millimeter with Jinko's TOPCon cell. The other modules are using 210 millimeter solar cells with PERC technologies.
Fantastic. Roberto, we have another few questions coming in for you. Previously, Jinko were kind of targeting around 10 gigawatt in sales for N-type products. Given this capacity is now moving on towards kind of 40 gigawatts by the end of the year, is there any kind of expectation that's been put in place, or is that very much kind of a wait and see?
What expectation in which sense? What do you mean exactly? I mean, yes, we plan around 42 gigawatt capacity of N-type. That's correct. So we have already one factory in place which can deliver 16 gigawatt. There are 3 more in construction, and by the end of the year will be 42 gigawatts. So to start 2023 with, I mean, such a capacity.
Fantastic. I'm kind of just picking up questions once again. If you do have questions, feel free to submit them. I'm just picking through some questions now. This might be a question for both of you, I guess. Obviously, this is quite an industry-wide transition to N-type, with not just TOPCon but heterojunction also being discussed as well. Different manufacturers do have different assumptions that are around degradation rates, especially around LID and LTID. Roberto, perhaps you could give a bit more into the assumptions around your LID rates, and perhaps you might be able to contribute with what you're seeing kind of across the spectrum, I guess.
Yeah, I mean, regarding LID and LTID, it's the point is this technology comes naturally with cancelling this phenomena because it's a chemical action. Now, the point is we have tested it internally, and we suggest to calculate a first-year degradation about 0.2, 0.3%, considering both phenomena. Right now, we are also by the end of March, middle of March, we will also get the certification and third-party reports for LID and LETID. So just wait for it, and we will share all the results and all the reports. Yeah.
Excellent. Well, I know there's a few other questions that are coming in around the presentations today. Yes, all of our presentations will be available shortly after, which does include both Roberto's and Xiao's presentations and the kind of resulting Q&A. I'm afraid that's all we have time for this afternoon in terms of kind of our live engagement with you. But once again, a reminder that if you continue to ask questions, or if you have any other questions that you want to ask, do feel free to submit them with your kind of contact details, and we'll kind of aim to get back to you as quickly as we can. A huge thank you to JinkoSolar and TÜV NORD for supporting the webinar today, to Roberto and to Xiao for presenting, and indeed for all of your attention this afternoon. Thanks again, and we do hope to see you next time.